Hello and welcome back to A Boring Revolution, your #1 news source for everything in regards to the Boring Company and Elon Musk. We've got an excellent little talk for you today. We are here, as you can see on this picture here, we are at the site of SpaceX in Hawthorne. We have acquired this land here, if you watch my previous video, and we have begun to dig a shaft at the rear of this site. So, let's have a look. So, Elon Musk's Boring Company breaks ground on Hawthorne Loop Elevator, episode 14. Construction has commenced at Hawthorne. Now, the tunnel had already been pretty much 95% complete as of a good couple of months ago. If not further back. It has been stationary. There's been no work being undertaken by the tunnel boring machine because they intend to extract the cutter head and possibly the entire machine as well, and they intend to do that at this site. So what are they doing? They are building, they've been building for about a week now, maybe just under a week, a pit or shaft to extract the cutter head. It's approximately 30 foot deep, maybe slightly more, maybe 35 foot deep, in and around that kind of area. They will then convert this shaft into a loop elevator. So they'll dig the shaft, they will have the TBM break through into the shaft. They will then detach the cutter head and remove that, because that is one of the heaviest elements, in excess of 200 tons. They'll extract that, then they'll probably dismantle the machine, and then they will build some kind of elevator system, and possibly build some kind of metal frame inside the shaft, because the shaft will be a lot bigger than what is required, and then they will build their elevator there and start testing the system. So the work is taking place at 412 120th Street in Hawthorne. It's right next to SpaceX. It's on the opposite side from the existing launch pit. So I expect the 1.15 mile Hawthorne test tunnel to be completed before the end of the year / Christmas. They've not got far to go. They've maybe only got 100 foot or so to go with the actual TBM. So I can't imagine it's going to take them that long to restart the TBM and then break through. It's just the actual construction of the shaft that's going to take up a certain period of time. How will they build it? Well, we're not 100% sure. We have some pictures, although it's not exactly clear. Basically, they've got many options if they want to do it. It's just whatever the options are for the contractor. Really, the contractor can pick a method. They're all good. It'll all come down to cost and how quickly they can do it. Often you either get one or the other. So here we are. Here's that picture from earlier. That's 120th Street here, and here is the plot of land, and behind that there is a parking lot, and that is where the shaft has begun construction. Here are some pictures. These pictures come from Teslarati. I will link the article below. I believe it comes from a gentleman called A. Scott. However, again, I will link that below so that he gets credit for taking the pictures. What have we got in this picture? We've got a long reach excavator. So the excavator will sit on the outside of the shaft and then excavate from within. Certainly initially. And then they have the ring beam, which is here. It probably comes in around 8 pieces or 10 pieces. Let's count them up actually. 12 pieces. So it's 12 pieces. They are connected together and they form part of the ring beam, which helps reinforce the actual walls of the shaft, or the lagging, or both. So It looks like a circular excavation to me, and the fact that the ring beam is curved kind of confirms that. This picture is awful, really, really awful, but it just gives us a good insight of what's going on. Here is the crane, a jib crane, and we have ventilation duct here. Just about make that as a ventilation duct, and we have some fill material here. So that's about all we can glean from that photo, really. We can't see into the excavation. It would be awesome if someone would fly a drone over the top. We could get a look in, or maybe the Boeing company would post some pictures for us to have a look at. But as of now, that's all we can see. We can't see what the actual shaft is constructed of, whether it's concrete or steel. So here is Google Maps, and as you can see via the green arrow here, sorry about that, guys. Here it is. That's where the plot is, just in this little square here. It's about 1.15 miles long. This start area here might be slightly further down, and obviously it's coming across here, it's curving, so again that might add to it. It certainly will add to it. So what can we build? How can we build it? How can we get it done properly, ensuring there are no cave-ins? Because that is a tunneler's worst nightmare. You start excavating and there is a cave-in. There are many ways to do it. This is a project that I'm quite familiar with. It is Crossrail. This is the site of where the TBMs entered the system. So that'd be a launch pit, as you like to call it in the USA, a TBM launch shaft. It's made with concrete. The concrete is poured on site. It is not cast off site. It is poured as a liquid on site. How do I know this? Because the walls of the tunnel are extremely rough, and you just can't see it on the bottom of this picture, but they are extremely thick. And the reason for that is because the soil conditions are very, very poor in London. It is kind of like, if you imagine peanut butter, if you put peanut butter in the fridge and then try to spread it, it's a bit like that. It's a very soft clay. It is not good to work in, and they've had to cast in these very thick shaft walls. And even at the bottom here, they've had to further reinforce it so they can put the TBMs through these tunnels here. That is one option for the Boeing company. However, it is very time intensive to do this. It requires a lot of expertise, a lot of manpower. So they probably won't do it like this, but it's just a good little example of what needs to be built. Here's what they do in Europe. We tend to do precast concrete segments like this, and pretty much every shaft in France is dug like this because they love using concrete for everything. Really like concrete, especially precast concrete like this. And the idea is you build up your rings, you stack them on top of each other, bolt them together, and then you excavate inside and you undercut the ring, which then slowly falls down into the excavation, and you continue to pile more weight on top of it. You can even use hydraulic rams, although with concrete this thick, this is nearly 10, 11, maybe even 12 inches thick, the sheer weight of it will just cut straight through the ground. So all you've got to do is excavate underneath it, undercut it, and boom. And because it's got reinforcement already in there, it is extremely strong. It's made in factory conditions, so it's just the right temperature and just the right amount of water for the perfect concrete mix. I think potentially that could be used. Potentially, I'd give it a good chance. They didn't use that on the actual other side of the SpaceX campus, the launch pit there, but they could use it here because it's a proven, tried and tested system. This is interesting. The soil conditions here I would consider to be very competent or very strong. Therefore, they have used what's called soldier piles, which are these steel H-beams here. When we looked at the Boeing company documents, they referred to these as H-beams, and then these pieces in between are lagging. Now, the lagging can be steel, it can be wood, it can be concrete. In this particular excavation, they didn't require any. They either didn't require any, or I'm unable to make out what they are, because I can see the steel, but I can't see what's in between them. It just looks like the ground conditions are excellent, so they haven't really required that. So they have this falsework here and these props, and that just ensures that the soldier beams stay at a perfect 90 degrees and there is no deflection in the walls of the shaft. Because this is a rectangle, they have to reinforce the corners. At the Boring Company Hawthorne shaft, they have got a circular excavation, which is good from an engineering perspective because it acts like two arches. Those arches compress, they compress the ring, and therefore it works perfectly. There is not going to be any failure points in the corners. It's a perfect circle. So it's unlikely that they will use this system. Here is the shaft. How long ago was it? 16 months ago, 18 months ago, when they started this project, maybe less than 16 months actually. Again, they've used soldier piles. However, unusually, they've used these steel sheets. They are about an inch thick. They are quite considerable. I've never ever, even at university, when I was obviously like being given examples of various shaft construction techniques, I was not made aware of this system. It might be because in Europe it's not economical to do it like this. However, it is interesting to see it. It does make sense from a structural perspective. But yeah, again, this is rectangular, so they're probably not going to do it like this unless they use curved steel panels instead. It's just another one. Excellent. This is a TBM breaking through a shaft. Again, you've got this falsework here with these knees here to reinforce the corners. They've actually had to correct the falsework so that they can break the TBM through. Can you see here? They've had to cut it there and cut it there. This is made of timber. This would never ever get approved in Europe because we hate using timber, even though timber is an excellent material for construction. But it's just for some reason we don't like using it because I'm guessing its actual structural performance is quite variable depending on where you source the wood from or the timber. The face of the TBM has been removed here, as you can see, and then I imagine they're going to dismantle the rest of this TBM. This is what it'll look like. If you imagine this, ignore that excavator there, that's a bit silly, but you've got two shafts either side of the SpaceX campus, and when we get to the other end we extract the TBM. Now, again, we're not going to use wood, but because this is a circular excavation, I have included this in our examples because I like it quite a lot. It's very interesting how they've doubled up the timbers here. These are more like joists. They're at least 3-4 inches thick. Very, very strong. Here's the ring beams. They look almost identical to the ring beams that we pointed out before in the picture from Teslavati. Again, it reinforces this excavation, prevents it from collapsing, and they're chained here at the top, and then they have these, I don't know what you call it, they call noggins, or maybe there's a better technical term for that. But again, I don't think we're going to use timber, but it may look similar to this. They may just switch out the wood for metal sheets, curved metal sheets. Now, here's possibly one of the best examples I could find. When I've worked in excavations in the past, and I've worked in some very deep excavations, well, not very deep, but you know, quite a lot deeper than a lot of traditional builders. I've used sheet piling, and sheet piling is a very, very good system because it's interlocking. It prevents, or generally 98% of the time, prevents water ingress into the excavation, which is perfect. And because of its shape, it's engineered in this way, it is very resistant to deflection, which is excellent, which is what we're after really. If the ground conditions are average to poor, using sheet piling is definitely the way forward. They've also got these in situ concrete beams that have been cast on site. Again, this is very useful for what we are looking at doing with the boring company, although they will probably use steel ring beams rather than cast in situ. But I'd imagine from above, other than this ring beam being made out of concrete, this is what the shaft will look like in Hawthorne. And here we go. We've got, obviously once we've constructed our shaft, the TBM then has to break through into the shaft. If the shaft walls are made of concrete, you can construct a specific area here where the breakthrough is going to take place. Obviously this concrete here will be weakened. It's either produced with a higher than average water content or higher than average fine aggregate or sand content to make it weaker than the other parts of the excavation, or you actually drill holes into it to make it fail in a specific way. So let's have a watch of this. Oops a daisy. So as you can see, it is failing. It's not actually that thick. It's only around 4 inches of concrete. It's beginning to fail at the edges here. We've got these neat kind of like catching. I've never seen it before. It's like a kind of catching net. And look how beautiful this just falls apart in one piece. I've never seen a cleaner breakout than this. Look at that, beautiful. And that's how it should go. That is a 10 out of 10 perfect breakthrough. Hopefully that's what happens with the boring company. So, I hope you've got some questions. I had some questions myself, which I wrote down. Hopefully the answers that I give you will inform you about what the boring company is going to do. Some of it is guesswork predictions, but it's based on my own personal knowledge of working in the construction industry. How long will this take to build? So they've already started. I'd imagine they've been at it for nearly a week now, maybe slightly under a week. They've got between 7 to 12 weeks left, I'd say. So it'll probably finish just before Christmas, maybe the week before Christmas, I'd say. There's not a great deal to do. It's not immensely complicated. It's just you've got to make sure you've got the man hours and the materials ready for you to do it there and then. Will we need several hundred of these loop elevators in Los Angeles? Yes, we will. We'll probably need 1,000, 2,000 maybe. They probably won't be constructed like this because this is a very kind of special example of where they're extracting the TBM cutter head, and I'd imagine that they won't do that too often. The actual secondary tunnels will probably be dug with a different machine, maybe not even a TBM. It might be dug with a tracked machine because they won't be that long, and they will use a rectangular excavation for most of the loop elevators. And the best way to do that would either be with CFA piles or micro bore piles, and they can be done very, very quickly. indeed, very quickly. So don't be discouraged by this particular manner in which they do it, because they won't be doing this very often. They'll have a specific way for doing loop elevators, especially when it's at the side of a road or in a park or under a building. There'll be a completely different method of doing it. What will happen to the TBM Godot? I'd imagine the cutter head will be reused. It will be refurbished and then reused on a different TBM. Some of the components from this TBM will be removed. It will probably be dismantled into several hundred pieces. Some of it will be scrapped and some of it will be used in another TBM or maybe even sold as parts. They are building another TBM, Line Storm, which is far more advanced than this one, a lot faster, a lot more automated. So a lot of this machine will unfortunately get scrapped, but hey, that's innovation for you. Isn't this mad expensive? Yes, it is. It is mad, especially when they're doing it this way. They've had to acquire that land as well. They're using a lot of steel. The price of steel is not so bad actually at the moment. I presume it's probably less in the USA, so it won't be too bad. But in the long term, this is a solid investment. I can't tell you exactly how much. It'll probably be in the 7 figures, if not far way into the 7 figures. What is the point of this Hawthorne test tunnel? Well, once they've actually done the breakthrough and constructed the loop elevator, that'll be a whole system that they drop in. I imagine there'll be lots of beams and columns that they install, and then they install the lift inside that. Then they will actually start testing the pod. Now, I don't know if they're actually building a pod at the moment. I presume they are. I presume somewhere in some secret hideout they have built a pod that looks like the ones we see in our pictures, and they're going to start testing it in the tunnel, probably in January or February, maybe slightly later than that. And they'll actually start taking passengers, because he said that he wants to test it with people, and you can maybe buy a ticket for like $1, and then you shoot down there, you go both ways a couple of times, and then they can test the system, see how fast they can go, see how much the tyres are wearing down, because it'll probably be 16 hours a day, like testing the pod, making sure that it's running correctly, and testing all the various systems, seeing how the tunnel holds up to the external pressures. When will we see a pod inside the tunnel? So again, it kind of answered that above. I'd imagine it'd be around February. Are you excited? Yeah. Look at my face. Look at this face. Very excited. This is what I live for, seeing things like this. I worked on a big job in Leeds, and that was a huge excavation, and I learned so much working on that job. I went on to various other jobs as well that I learned from, but never as deep an excavation as that one in Leeds. And yeah, it's an interesting job. They've got many options for how they're going to do it. I'm pretty confident the actual geology or the soil conditions are reasonably competent, are solid. So I think that they'll really whiz through this quite quickly. Once they've got the loop lift in, hopefully they've already designed it. I imagine they could design it now. They know the diameter of the shaft, so they could just build it off site and then drop it into place, in January, the first 2 weeks of January, and then boom, they can start using it. Oh yeah, so shout out again to Blake, who has this channel, In the Hyperloop. Great channel, really enjoy watching it. If you are interested in the Hyperloop, there's so many companies operating in this space, and what Blake does is a really awesome thing. He kind of combines all the information into one very short video. It's around 8 or 9 minutes, and then boom, it's all there for you, bite-sized chunks. Really exciting sector this, so please go to subscribe to Blake's channel. His website is www.inthehyperloop.com. This is the end. Thank you for watching. Really appreciate everyone who's been watching. We are up to 60 subscribers. I am super happy, because we just seem to be gaining maybe 5 or 6 subscribers every week. At this rate, we could be you know, 200, 300 subscribers by this time next year. You never know. It's great. Really happy. Hopefully it continues. Thank you for watching. Please like and subscribe. And peace out, guys. Thank you again. Remember to hit the bell icon and subscribe to all our videos. Thanks again and goodbye. Don't be boring. See you later.